In this episode, we're going to look at verifying single area OSPF version 2. I'll show you how to do it, and we'll talk about the concepts along the way. We are the network administrator for a branch office of a larger organization. Our branch is adding a new wireless network into our branch office LAN. The existing network is configured to exchange routes using OSPF version 2 in a single area configuration. Our task is to verify the operation of the existing OSPF version 2 network before adding in the new LAN. When we're sure that the current OSPF version 2 LAN is operating correctly, we're going to connect the new LAN and verify OSPF routers are being propagated for the new LAN. As a branch network administrator, we have full access to the iOS on our routers, but we only have read access to the enterprise LAN routers. Greetings to all my tech heads out there in the KevTechify nation. And if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 2.6.6 Verify Single-Area OSPF. Got our packet tracer lab open. On the left side, I have our topology and our working area. On the right side, I have the instructions. For the instructions on the bottom right, I have the actual packet tracer activity window that opens up that has all the instructions. But on the top right, the majority of the top right side, I have the Word document of those same instructions. The reason I have the Word document is we've got some answers to, or some questions to answer as we work through the lab. The Word document will allow me to type my answers in and save those. Over on the left side, we have our topology. As you can see, we're starting to get into a little bit more complex network. We have 3 routers to start with in our network forming our core. Each one of those have a network coming off of them. R2 even has an ISP connection. We have our addressing table over here in our instructions. We have the device, the interfaces, the IP address, and the subnet mask, and then we even have the default gateway listed for those devices that need them. We got 4 routers. We have our ISP router, a handful of PCs, and a laptop. What we're going to do in this lab is we're going to look at OSPF. We're going to go through, analyze it, look at the different settings. The instructions. Part 1, verify the existing OSP network operation. First thing they do is they give us a list of commands right here that will help us in exploring our network. Step 1, verify OSPF version 2 operation. Wait until STP is converged on your network. You can click the packet tracer fast forward time button to speed up the process. Continue only when all links are green. What they're talking about are these green triangles in here. If you have any yellow, amber, orange circles in here, your switches are still going through the negotiation phase. And to speed this up, because this is a simulation, we can click on the fast forward button down here on the bottom left. You can go ahead and click on that once, twice. It speeds it up until you get all green lights up here on your network. Once we have that, log into router R1 using the username BranchAdmin and the password branch123. Execute the show IP route command. We're going to go ahead and log into R1. I'm going to click on R1 right here. Bring this up. Click on the CLI tab. And what I do is I make this window a little bit bigger going right to left. That allows the data to be formatted better witho't having a weird wrap happening. And so to log in here, we log in as BranchAdmin, capital BRANCH. Okay, let me start typing that over. Capital BRANCH, capital ADMIN. Password for that is capital B branch1234. Log in. We should be now in privileged exec mode. We can tell we're in privileged exec mode because we do have that, the name of our device R1 followed by the pound sign, the hashtag, the octothorpe, or my personal favorite, it's the waffle sign because it looks like a waffle. Now we can go ahead and type our command show space IP space route. When I do the show route, your show IP route command, it has the more here. That more means there's more data than that would fit on one screen. So you can go ahead, either hit enter, takes you down a line, or we can hit the space bar, scrolls through there. Here is the entire information of the show IP route statement. Up on top, we have what the codes are. Those codes are listed at the beginning of each line. Then we have the gateway of last resort. It's showing us the gateway of last resort is set, and we are looking at any traffic. Any traffic that doesn't match any one of these routes in the routing table, we're going to send to this IP address, our default gateway. Question: how did R1 receive the default route? R1, we got our default route here, but if we look up here in the codes, we have this asterisk. That's the Shift 8 key. It says it's candidate for the default. We can go down here, look in our routing table until we find it. We find it right there. And so that means that this line here is the default route. How this line was learned is the first letter in the line. That is a capital letter O. Capital letter O up here in the codes mean it's OSPF. R1 learned about the default route, the default route from OSPF. Our answer here is the default route. Default route was learned through OSPF. I'll default correctly. Next question is, from which router did R1 receive the default route? Which router sent the default route to R1? When we look here, once again, we are looking at this line here that has that asterisk in it. We're looking here, and it came via 172.16.3.2. 172.16.3.2, if we scroll up to our addressing table, 172.16.3.2 is on R2. R2 is the router that sent out the default route to R1. That's the answer to our question. Router R2. On to the next question. How can you filter the output of show IP route to show you only the routes learned through OSPF? Well, there's two ways of doing that. We can use the show IP route command, so show IP space route, and if we put a question mark, it'll show us all the options, and one of the options is to put OSPF in there, and that will show us all the routes learned through OSPF. So we go OSPF here. Now notice all the codes here are just the O's for routes learned through OSPF. The other way would be to filter out the show command. We could go show space IP space route, and then we could use the filter. That's the pipe sign. That's the key above the enter key, but you got to hold the shift down. That's that up and down line. And then you can put a space in there. And what we want to do is we want to include any line that has the O in it. Once again, we're looking for the O right here because that's the code at the beginning of the line. And if we hit enter, we see that it has those lines included. Now, it did include some of the code lines from up here because they did have a capital O in it. So we got a capital O in that line, capital O here, capital O there, capital O there. It included all those, but when we got down to the routing tables, we only have the 4 lines here that we learned through OSPF. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. The answer to our question is a two-parter. You can use either, the first one we typed in was show IP route OSPF. Make sure I type that in. Or use, and then once again, it's the show IP route, but then we can filter to include anything with a capital letter O. Takes care of part A. On to part B. Execute the show IP OSPF neighbor command on R1. I'm going to hit enter back here in our R1 window just to give us some clean lines. That way, if I ever have to scroll back up, I know where I see the clean lines right after it is where I started my next command. Now, the command we have to enter in is show IP OSPF neighbor. When I show the command, it'll show me all the neighbors that I have adjacencies built with. Looking at our diagram, I'm going to shift this over. We are on R1 right here. R1, and then it's saying that one of our neighbors is 2.2.2, which if we look at our addressing table, doesn't show up in our addressing table. 2.2.2 doesn't show up here, but that would be the router ID that we manually set. We can come over here and look at the address here, 172.16.3.2, 172.16.3.2. We find that IP address is right here, and that's on R2. So the first one is R2 is our neighbor, which if we look at our topology, we're on R1 here, and they're saying our neighbor is R2, which on this connection, we're right here. This is that connection, that's that adjacency. R1 has a neighbor of R2, and then the next line is the 3.3.3, which is a router ID, which doesn't show up in our addressing table, but if we come over here, we can see we have 192.168.10.6, 192.168.10.6. Right here is that IP address, and that's on R3. So this is the neighbor of R3 right here. And if we look at our diagram, that's what we're showing us right here. R1 and R3 are neighbors. Let's go look at our questions. Which routers have formed adjacencies with R1? So which routers here have formed adjacencies? Well, like we just talked about, it's router R2 and router R3. What are the router IDs and states of these routers shown in the command output? So it's asking what are the router IDs, that's our neighbor IDs, and then what is the state? Well, we got two lines. First one, router ID is 2.2.2.2, and then that is a full state. And then we have 3.3.3.3, and that is also a full state. On to the final question for B. Are all of the adjacent routers shown in the output? Like we talked about a minute ago, we have router, we're on R1 here. The first line for the show IP OSPF neighbor is router 2, and the second router listed is R3. That's right here. R3 is that router. Those are the only routers we are connected to. Yes, there's R4 down here, but it's not connected to anything. We're going to take care of that in a little bit. But right now, that's the only two routers that are in our network, or only other two routers. And yes, we have adjacencies with all of those network, or all of those routers. The answer is yes. Using the command prompt on PC1, ping the address of ISP router shown in the address table. Is this successful? If not, do a clear OSPF process command on the routers and repeat the ping command. Okay, I'm going to minimize the R1 window. I'm going to open up PC1 right here. Click on that. I'm going to go on to the desktop app and open up the command prompt app here. I'm going to go ahead and ping, and then we are pinging the ISP router. ISP router has an IP address of 64.100.54.5. Let's go ahead and put that in. 64.100.54.5. And we're sending out the echo request, hopefully getting back our echo replies. The first one out of 4 failed. Why did it fail? It had to do some ARP lookups in the process, address resolution protocol, and then the last 3 work. To verify that we're going to have a 100% success rate, I'm going to repeat the command. Simply hit the up arrow once and press enter. Here's 1, 2, 3, and 4. 0% loss, 100% success. Takes care of step 1. On to step 2. Verify OSPF version 2 operation on R2. Now we're going to take a look at R2. Right here's R2. I'm going to go ahead and click on it, slide this window over, make it a little bit wider, going left to right, and click on my CLI tab. I'm going to hit enter. We have our username and password here again, BranchAdmin in branch 123. So I'm going to go ahead and type in capital B R A N C H, capital A D M I N. And our password is capital B R A N C H 1234. Logs us in. We are into privilege exec mode here on router 2. Execute the show IP route command. Show IP route. Hit the space bar to get all my information displayed. We have our codes. We have our gateway of last resort, our default route, and then we have all the routes in our routing table. How did router 2 learn the default route to the ISP? How did it learn that route to the ISP? Here's that default route, the gateway of last resort. If we look up here in the codes, once again, we're looking for the asterisk, and that's the candidate for the default route. We can look in our table until we see the asterisk. Right here is our asterisk. And the letter right before it's an S. What the S stands for, it is a static route. It's a static route, meaning you manually, as the administrator, configured it. So how did router 2 learn of it? It was statically entered by the administrator. On the B, enter the show IP OSPF interface gig 00 on R2. Okay. I'm going to hit enter several times. Give me that break in there so that way I can tell where in between where I entered commands. And the command here once again was show IP OSPF gig. Nope, I forgot the word interface. Gig 0/0. It's going to give me information for gig 00. Anything that has to do with OSPF. First question. What type of OSPF network is attached to this interface? The type of network that is attached is, if we start looking at the information right here, second line down, it says network type of broadcast. So broadcast is the type of network. Broadcast. Are OSPF hello packets being sent out this interface? Explain. Okay, so are hello packets being sent out that interface? Well, let's see what information we can get here. Once again, we're looking at the information, not necessarily getting that. Designated router ID, interfaces, no backup designated router on this network. We have our time intervals of hello 10, dead 40. Once again, dead interval is 4 times the hello. No hellos. There's no hellos. And it's because it is a passive interface. You as the administrator set up gig 00 as the as a passive interface. Our answer, no. The interface is configured as a passive interface in OSPF. Next question. Using the command prompt on PC2, ping serial 001 address on R3. I'm going to minimize R2, and we are looking for PC2. I'm going to go ahead and click on PC2, click on the desktop tab, click on the command prompt app, and then I'm going to go ahead and type in ping, and we are looking for serial 001 on R3. I'm going to scroll up to our addressing table. I'm looking for R3, serial 000, and I'm going to ping that IP address, 192.168.10.6. Coming back to PC2, I got the word ping in there. All I have to do is type in my IP address, 192.168.10.6. And the pings are successful. Pings are successful. I pinged the wrong interface. Pinged the wrong interface. On R3, serial 001. Oh, I pinged the wrong interface. Let's go ahead and ping the right interface now. Ping, and then 192.168.10.10. And there, that worked also. Pinging the correct IP address of serial 001 on R3. Answer question C. Was it successful? Yes, it was. On to step 3. Verify OSPF version 2 operation on R3. I'm going to go ahead and minimize PC2 and open up R3 here. Slide it over, make it a little bit wider, going right to left. Click on the CLI tab. Hit enter. No passwords here for logging in. I can just hit enter. I can go ahead and type enable. Gets me into privilege exec mode. And then the command we're going to enter now is show IP protocols. I hit enter a couple times just to give me that clear break. Show IP protocols. Gives me some information. A couple things about filters, but then it tells me what my router ID is. It's 3.3.3.3. Number of areas for OSPF. Maximum path is 4. The networks I have in my routing table right there. And then some information about the other devices in my area. Question for step 3A. Router 3 is routing for which networks? Which networks are we routing for? That would be these networks listed right there. This is the first network. We don't have to put the area. This is the second network. And this is the third network. So we can go ahead and type those in. 192.168.1.0. Second network of 192.168.10.4. And the third network of 192.168.10.8. Step 3B, execute the show IP OSPF neighbor detail command on R3. Okay, I hit enter several times to give me that clear break in there. The command once again is show IP OSPF neighbor detail. And now we get some in-depth information about each one of our neighbors. Here's our neighbor 2, and here is neighbor 1. Question: what is the neighbor priority shown for OSPF neighbor routers? This value is the default. Okay, so what is the neighbor priority shown for OSPF neighbor routers? Okay, let's see. Neighbor priority is 0. Neighbor priority is 0. And then the answer to our question is 0. Using the command prompt on PC3, ping the address of the ISP router. Okay, I'm going to go ahead and minimize R3. Click on PC3. Slide it over, click on my desktop tab, click on the command prompt app, and type in ping. And then we are pinging the ISP router. Scrolling up to our address table. Our address table, here is our IP address of our ISP router, 64.100.54.5. We can go ahead and enter that command in after the word ping, 64.100.54.5. And we received for 100% success for our ping. PC3 can ping our router. Was it successful? Yes, it was. That takes care of part 1. Now in part 2, we're going to bring the branch office local area network online. We're going to bring it into the connection. If we look at our topology, the bottom part of this green square right here, this is the branch office, and we're going to bring it into and connect it to the rest of our network. But before we get started, execute the show run and filter on any line beginning with router OSPF command on R4. Verify that the network statements are present for the networks that are configured on the router. What we're looking for is we're going to click on R4 here and see that only the networks that are directly connected to it are configured for R4. I clicked on it, make the R4 window a little bit wider, going right to left. Click on my CLI tab. Hit enter. No password. Allows me to type enable. Gets me into privilege exec mode. And now I can enter in the command. Show running config. And then filter it on any line that begins with router OSPF. When we do that, we start, first time it finds something that matches after the begin, it prints that line and every line after that. And so here's our OSPF settings on router 4 here. We have the router ID is set to 4.4.4. We have a passive interface set on the gigabit Ethernet 001. That would be the connection to the LAN. We don't need to send OSPF updates to the LAN because there's no OSPF devices there. And then here are the two networks. When we look here, the two networks that are configured, the first one, 192.168.1.0, that's this network. That's where we're going to connect R4 into shortly. And then the second network is 192.168.11.0. That's the bottom part of this. That's after router 4. Router 4 is going to have two networks connected into it. Now our question reads, which interface is configured to not send OSPF update packets? Which one? That would be our passive interface. That is gig 001. Our answer to the step 1 question is G0/0/1. On to step 2. Step 2, connect the branch office router R4 to the OSPF version 2 network. I'm going to minimize the R4 window here for a second. Step 2A, using the correct Ethernet cable, connect the G000 interface on R4 to the G01 interface on switch S3. We're going to make that connection right here between these two devices. These two devices is where we're going to make our connection. From the 000 interface on the router to the 01 interface on the switch. We need to use the right cable. The right cable to do that is a straight through cable. Now, to grab that, I'm going to go down to the bottom left of our packet tracer window. There is this orange lightning bolt. That's the connections tab. I'm going to click on that. And then to the right here is all the different connections that are available. I am going to look for the copper straight through one. The copper straight through one is actually the third one over. It's a black straight line on a diagonal. I go ahead and click on it. Now my cursor looks like the end of a cable you would plug into an Ethernet port. It has the RJ45 on it with an N coming out. That kind of gives you the idea we're going to plug it into something. First one we're going to go to is R4. So I'm going to click on R4 and it gives me a list of available ports I can plug it into. And we are plugging it into gig 000. Go ahead and click on that. And then you can see we have one end of the cable that's connected to R4 and then we can plug it into someplace else. That someplace else is on switch 3, the gig 01 interface. Right here is switch 3. I'm going to go ahead and click on it. Gives me a list of all the available interfaces. Notice 01's not listed, but what are we connecting it to? We're connecting it to gig 01. The fast Ethernets are all listed first, and then at the bottom is the gig. And right here is our gig 01 where we're connecting it to. Go ahead and click on that. That makes our connection. That gives us our connection there. Now the switch is going through the negotiation process. That's why we have the amber light right here. As soon as it's done negotiating, it'll turn to a green triangle. If you're impatient like me, what we can do is click on the fast forward button down here on the bottom left, the packet tracer window. Go ahead and click on it once, and now everything is green. That orange amber light has changed to a green triangle. We did our connection. Now it says use the show IP OSPF neighbor command to verify R4 is now adjacent with R3. Here's R4. It's connected through a switch to R3. That should show an adjacency. I'm going to go ahead, open up R4. We can see that we did plug the cable in here. Our line protocol on gig 000 went up. And then we started participating and formed an OSPF adjacency with the device that has a router ID of 3.3.3.3, which is commonly known as R3. But we can go ahead and enter in the command. I'm going to hit enter several times to get me to a clean break. That way, if I have to scroll back up to find out where I started, it gives me just that clear break in there. And the command we are entering is show IP OSPF neighbor. Right here, it gives us that we have one neighbor. If we look at our network in this green box right here, R4 only has one neighbor. That's R3. That's where we are participating in our OSPF. We only have one adjacency. That's router 3, which router ID is 3.3.3.3, or it has an IP address of 192.168.1.1. That's that interface right here. So the show IP OSPF neighbor command is showing we have the one adjacency to R3. What state is displayed for the R3 router? Looking here, we have R3 here, which is a router ID of 3.3.3.3. Underneath it, it says it is we have a full OSPF communication with it, and it's identifying the far end. It's identifying R3 as a designated router. So what is the state being displayed? It's full communication for OSPF, and it's identifying the far router as a DR, a designated router. Step 2B, using the show IP OSPF neighbor on R3, determine the state of R4. I'm going to go ahead and minimize R4 right now. Bring up router 3. We don't have a password on there. So we can go ahead and type enable. I hit enter, give me that clear break area again. Enter in the command show IP OSPF neighbor. And router 4, once again, had that router ID of 4.4.4.4, so quad 4. That is this adjacency. That is this neighbor right here we are looking at. This is the one we are looking at. What is the state of Why is the state of R4 different than the state of R1 and R2? Now, if it doesn't show up here in your neighbor table, you may have to wait for OSPF to converge and learn about everything and go through the election process. You can cheat and get impatient and click the fast forward button. But by the time I got here, mine was listed successfully. Question: why is the state of R4 different than the state of R1 and R2? Once again, when we look here, we see that we have these 4 devices listed. The one with the router ID of all 4s, that's router 4. The one with the router ID of all 2s, that's router 2. And the one with the router IDs of all 1, that's router 1. R4 says it has full OSPF communications, but then it's listed as a BDR. But the 1 and the 2s don't have anything after it. It doesn't say it's a designated router, it doesn't say it's a backup designated router, or it doesn't say it's a DR other. It doesn't have one of those 3 choices. It's just blank. Well, why is it blank? When we look at our diagram here, between the device we're on, R3 and R4, this is a multi-access network. There's a switch in between. We could have multiple routers connected into it. Because we have multiple routers, we go through the election process where we have a designated router, a backup designated router, and then all the other devices that aren't one of those 2. When we come back and look at our original core network, each one of these connections here, the connections between R1 and R2, the connection between R1 and R3, and the connection between R3 and R2, those are point-to-point connections. And because they're point-to-point connections, they're never going to have more than just those 2 devices on there. And we don't have to have the election to figure out our designated router and our backup designated router. And then that is our answer here. Why is the state of R4 different than the state of R1 and R2? R4 is on a multi-access network that requires the election of a designated router and backup designated router, while R1 and R2 are on point-to-point networks that do not participate in the elections. On to question 2C. Using the command prompt on laptop, ping the address of PC2. Using the command prompt on laptop. So I'm going to go ahead and minimize the R3 window. Click on the laptop right here. Pulls up my window. Click on the desktop tab. Click on the command prompt app. And then I'm going to ping the address of PC2. So ping, scroll up to my address table. PC2's address is 172.16.2.2. I can go ahead and enter that in, 172.16.2.2. And that ping is successful. Answer the question, yes, it was successful. That was Packet Tracer Lab 2.6.6 Verify Single-Area OSPF version 2. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.